Hello everyone, this is Mrs. Denton, and in this video we are going to look at the 5 ways to prove that triangles are congruent. 5 sounds like a lot, but I hope it's all here laid out nicely for you in these notes. First of all, you should have a piece of paper that has a front that looks like this and a back that looks like this. We're going to use both sides. This is another folding set of notes to help keep things organized, and it causes us to write less. So first thing to do is to fold your notes along the dotted lines. Fold that way with me. So we should have AAS, HL, and FOSS shortcuts on the right, and then SSS, SAS, and ASA on the left. So it should make 2 little folded doors. Okay, the other thing you'll want to do is to snip and make 6 windows. So snip right on the solid lines, like so. Okay, so I'm going to have 6 windows total when I'm done. All right. Now, if these margins bug you or anything, feel free to snip the margins off. They don't bother me, so I'm just going to leave them right there. All right, so let's get going here. So there are 5 ways to prove that triangles are congruent to each other. Okay. The first way we're going to look at is this SSS pack here. Let's start here. SSS stands for side, side, side. Okay, so let's open up and see what that means. This says that if 3 sides of one triangle are congruent to 3 sides of another triangle, then those 2 triangles are automatically congruent to each other. So if I have not been told that the triangles are congruent, then I need a way to discover if they're congruent. Well, this is one way. If you can figure out that 3 sides of a triangle are the same length as 3 other sides of the other triangle, that's a mouthful, then the 2 triangles are congruent to each other. So here in this picture, I've got it marked very nicely with the tick marks, but if you want to color code it, it might go like this. Side AB is a corresponding congruent match to DE. Those are one set of sides that are congruent. Then we've got side AC as a match to DF. That's a second set of sides that are congruent. And then finally, we've got CB as a match to FE. Now notice we haven't said anything about the angles, and we don't need to. If we know that 3 sides are equal to 3 sides, that's enough to know the triangles are congruent. Let's write a congruent statement. I think I'll start with ACB. If I start with ACB, remember, order really matters. Triangle ACB would be a congruent match to DFE. Triangle DFE. Now, if you started with ABC, you would just need to rearrange the letters of the second triangle. Okay? All right. Now, let's see something different. Let's compare this to SAS. Let's go down the left side first. SAS. Open that one up. This one's kind of longer, and it's got something important in it here. All right, so first of all, we know that the S stands for sides. The A stands for angle, and this is just a pattern. Side, angle, side. SAS. So let's look at this pattern. Check out the picture. Here I've got 2 sides marked and 1 angle marked. Now the angle is very important. Let's fill in the blank. If 2 sides and the included angle, that's a fancy vocab word. The included angle means it's the angle that's stuck between the two sides. So the included angle, I'm going to highlight that because that's very important. The included angle would be angle A and angle D. These are the angles that are between the congruent sides. Angle C, E, B, and F would be considered not included. Okay, so if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then that is enough for us to know that these triangles are congruent. We don't need to know anything else about the other angles or the third side. This is enough for us to determine that the triangle is congruent. So again, if you want a color code, we've got side AB congruent to DF, and then side AC congruent to DE. Notice how everything is connected here. It's a nice flow. The side connects to the angle, which connects to the other side, which makes that SAS pattern. This is enough to know that the triangles are congruent to one another. Let's write a congruent statement. I'm going to start with CAB, just going down the pattern here. It does not matter how you write that first triangle as long as the second one matches. So C to A to B matches E to D to F. All right, notice again, one more time. I don't need to know any information about CB and EF. I don't need to know any information about these missing angles. What I have is enough to prove that the two triangles are congruent. All right, keep going down the line here. Let's go to ASA. Okay, ASA, angle, side, angle. It's important to see where the letters are in the pattern. The S is directly between the two A's. The side is connecting the two angles. So let's look at that in picture format. Here's the side. I'm going to highlight that one. Okay, we said that the side was going to connect the two angles, and there it is. The side is connecting the two angles. So here's this verbiage again. If two angles and the included side this time of one triangle are congruent to two angles and the included side of another triangle, then those two triangles are congruent. So this is the included side I'm talking about this time. Included means between, connecting, attached to. All right? So the included side has to attach the two angles here. This is angle, side, angle. So let's check it out. Angle A matches to angle D. Angle B is congruent to angle F. So all the parts that we're using in this pattern are connected to one another. An angle, a side, an angle. Sometimes I write that A-S-A so that I can determine what pattern's being used. A-S-A. So this is an angle, side, angle congruence. I don't need to know anything about the rest of the triangle. So I'm going to start with triangle ABC this time. Remember, this first triangle, it's totally random. You can write this in any order you want as long as the second triangle order matches. This would be DFE. It's a wonky triangle. Triangle DFE is the match. Now, in our previous lesson, we had to know all 6 parts. That's 3 sides and 3 angles. These are pretty much just shortcuts. There are 5 different shortcuts. We've looked at 3 of them so far. Let's keep going. Okay. Close this up. Looking on the right side this time. Okay. We're going to check out AAS next. Now, this is super important. You recognize that AAS is different than the previous one we looked at, which was ASA. These are different. The S has moved, and that's on purpose. Here, the side is not between the two angles. Let's see what that looks like visually. Okay, the side is pretty important here. I'm going to highlight it yellow. The side, AC, and DE, those are the congruent sides, but notice they are not connecting the two congruent angles. That has a special vocabulary word. It's called non-included. So let's write this out. If two angles and the non-included side of one triangle are congruent to two angles and the non-included side of another triangle, then these two triangles are congruent. Now, non-included this time, okay, non-included side is the side that is not connecting the two angles. That's different than our previous example. Our previous example said included side, so I would have to use side A, B, and DF, and you can check out that example. This is the non-included side. The angles that are a match are listed as angle A and angle D, and then angle B and angle F. Okay, I think highlighting it is very helpful because now I can really see that this side is not connecting my angles. Okay, so this is a different pattern. This is an S-A-A pattern if I go around the triangle. S-A-A, or if I go the opposite way, A-A-S. So this is enough for me to prove that the two triangles are congruent. I'm going to go with C-A-B because that's the direction my eye moves around the triangle, and that's a match to E-D-F. Excuse me. You are going to have to recognize which pattern we're using. So if you need to make a big deal about it like I am on these pictures by color coding it and labeling it, then do that. This is one side and two angles. The side is not included between the two angles, so this would be AAS. AAS. And that's a really quick reference to look at and have an example. Okay, this next example is very special. I'm going to put a big star beside it because it's super special. It's HL, and HL stands for a hypotenuse and a leg. Now, not every triangle we study has a hypotenuse and a leg. Okay, only a very special triangle has a hypotenuse and a leg. So take a look at this picture. Notice that this is a right triangle. I'm going to make a big deal about that because this pattern only works if we're dealing with a right triangle. Right? Triangles only. Only works on right triangles. That's where we get the vocabulary hypotenuse and leg. So, the hypotenuse leg theorem says that if a hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then that's enough to prove that the two triangles are congruent. We don't need any more information. So let's highlight it out here. We've got a hypotenuse, AC, congruent to another hypotenuse. So remember, hypotenuse is the one that's across from the 90-degree angle. If it's congruent to each other, as well as a leg congruent to another leg. Now remember, a leg, where's that? Oh, the legs are the sides that are not the hypotenuse. There are two legs. We could have used CB and FE, but if you have one set of matching hypotenuses, hypotenuse, not sure how to say that plural, and one set of matching legs, then that is enough to prove that the two right triangles are congruent. You don't need to know anything else about the triangle. All right, so let's write this out. Triangle, I'm going to go with ACB. ACB is congruent to triangle DFE. That's a hypotenuse, if you need to write that out, and a leg, matching another hypotenuse and a leg. All right, now, after you study all of these, let me zoom out here a second. After you study all of these patterns, they kind of all start to blend together. SSS, SAS, AAS, ASA, HL. HL is a little bit different, but these four really start to merge together, and I don't want you to get them confused. I also don't want you to think that any pattern will work. There are a few that are false shortcuts. There are some false shortcuts, so let's take a look at that one next. Okay, one false shortcut is SSA. Jot that here. SSA does not work. Okay, SSA would be two sides and an angle. So let me show you how that could not work. I'll zoom in here. There we go. Not every single time do two sides and an angle work. So check this out. Here's an SSA example of why it doesn't work. That would mean that two sides have to be equal and an angle has to be equal. Now check out where the A is. It's outside of the two sides, so it's the non-included side. So check this out. I don't know, maybe 2 centimeters and 2 centimeters. I'll start there. Okay, so there's a congruent sides. I need another congruent side, so maybe 1 centimeter. Now, the side I'm going to draw over here is going to go in this direction because the angle between them does not have to be congruent. Notice where the A is. It's not the included angle. The angle that has to be congruent is over here. Non-included, off to the side. Now, this is just my example. It's not my absolute best drawing I've ever done, but I think it'll work. Check this out. The angles are congruent enough for not having a protractor. And then I have 2 congruent sides. This side is a pretty good match over here, and this side is a good match up here. Okay, but these 2 triangles are not congruent in any way. These are definitely not congruent shapes. That's the sign for not congruent. So SSA is false. SSA does not prove that the triangles are congruent to each other. Not at all. Okay. Another one that students frequently confuse is AAA. AAA would stand for angle, angle, angle. So let's take a look at that. I'm going to make a really simple picture this time. Angle, angle, angle. Here we go. I could draw a fairly small triangle.
Hello students, this is Mrs. Dutton.
Oh
In
no!
this video, we are going to be looking at congruent figures.
It's one of my other videos playing in the background of this video. Crazy. Okay, well, let's start again. Let me draw just a basic small triangle here. Okay. Now, I can draw that exact same triangle much bigger over here. The angles are a match. I don't have a protractor, but that's a pretty good match. The angles are certainly equal to each other. They have partners, but there's no size regulation. This would be similar. Remember, we talked about this symbol similar. These are the same shape, but they are not the same size. They are not equal to each other. They have the same shape, but they are not the same size. So they are not congruent to each other. So be wary of these 2 guys. Students confuse these 2 all the time. SSA and AAA are not ways to prove congruence. Not at all. All right, so keep this handy. These are going to be your choices for proving triangles congruent. Happy studying, and really pay attention in this lesson because our next lesson is building proofs, and that one's pretty challenging, and it's completely anchored in this idea. So happy studying. Good luck.